Wait a minute. Oh, hello. Okay, so let's go ahead and go through an example of creating packages and creating modules inside of those packages, and then showing how we can actually access and use the modules from a main program. So I've downloaded the folder structure that was provided in the notes just to quickly show you what that looks like. Here's the folder structure that was created. So we have a main project folder that houses everything, and this is typically what you would do in Python. When you create a new project, you want to have a separate folder with its own directory structure associated with that. So in this case, the project is just called My Project, and inside of My Project folder, we have a folder that holds all the packages, and the root level folder there is called My Package. And you can see that inside of that we have two modules, Module 1 and Module 2. We also have another folder inside of My Package called Sub Package, which has another module in it called Module 3. Now, you don't necessarily have to have sub packages within a package. It just depends on how complex your package is, how many different modules, and how you want to organize it. But this is just set up this way to show you how to access these modules, and also to show you how the init.py files work together. The other key thing here is, if you notice in this directory structure, is that the main.py file and the My Package folder are in the same directory. So those two are in the My Project folder. So as you know, that when Python looks for modules that you've imported, it always searches in the same directory as the Python script that you're running. So in this particular example, we would not need to make any changes to our sys.path variable. And remember that sys.path variable is a list of strings where the strings are the paths to folders that we're instructing Python to look for modules in. So this is a great way to set up a project, because you don't have to make any change to your sys.path variable, and it just makes it a lot easier and seamless for your main.py program to access any of the modules and packages that you're using. Okay, so let's go ahead and take a look at each one of these individual files that we have. Let's start with the main.py file. So right now main.py has nothing in it. There's no code. Okay, and then let's go through the files in My Package. So in the My Package directory, we have Module 1 and Module 2. And so you can see that they both have basically the same code. Each one has a function defined. So Module 1 has function 1 or func1 defined. And all that function does is it returns a formatted string that contains the literal string func1 and then the name of the file using this _file. That's a special variable that will return the path and file name of the file that's being run, regardless of whether it's being run as a script or imported as a module. So it will always tell you the file name. And then it also includes the value of the _name variable, which, as you know, if you run a file, a Python file as a script, the name will be set equal to _main, and if it's imported as a module, the _name will be set equal to the name of the module. So in this case, I've got the if name equals main idiom down here, and we can test printing out the value of func1. And so you should be able to anticipate what the outcome is. So here we're running this as a script. So we should get something that says func1, and then the path and the name of the file, which is a path and then module1.py. And then we should get _main, since we're running this as a script. And let's go ahead and test that by running this. Okay, so you can see in our output here, that's exactly what we got. Func1, the path and file name, and _main, because we're running this file as a script. So that's Module 1. Let's take a look at Module 2. Module 2 does the exact same thing. The only difference is the name of the function is func2, and obviously the string is changed a little bit, func2. So if we tested this here, you can see since we're running that as a script, we get the same output as before, with the difference of being func2 versus func1. And then let's look at our other module file, which exists inside of the subpackage folder now, and that is called Module 3. And again, you see that familiar code. It's doing the same thing, except for it's printing out func3. And let's just test that and make sure that works. Okay, so you can see in each case we got _main when we ran these modules as a script. Let's take a look in our _init files. So I'm going to go back to our main one, which is inside of the My Package folder. So you can see right now there's no code in here, and there doesn't have to be any code in your init.py file. It's just that the presence of that file in that folder lets Python know that that directory, that folder, is to be treated as a package. And in our sub package folder, we also have another _init.py file with no code in it. Okay, so those are our files, and that's the code that we have set up so far. So let's go into main and let's demonstrate how we would import these modules into main.py. So since these are set up as packages, we need to use the dot notation in importing these packages. So for example, let's import my package dot module 1, and let's give it an alias, just to make it easy, as M1. Okay, and let's test that out. Let's try printing out a function call of func1. So let's print M1 dot func1. So again, I need to use the dot notation to reference where module 1 exists. It's inside of my package. And then I need to use the dot notation again to reference that func1 is a function object in the M1 module. So let's save and run that. Okay, so now you can contrast the outcome of running this function when we imported it as a module. You can see that it worked without error. It prints func1. It prints the location of module 1 because that was the _file variable that we had in the function. But now instead of printing _main, it prints out the name of the module with the dot notation. So this is how Python interprets the name of our module. So it's actually named it mypackage.module1. Okay, and we can just test that with the other modules as well. Let's import mypackage.module2 as M2. And then let's also import module 3. Now that is going to look a little bit different because we have to go one layer. Remember that module 3 is located in a sub package that is part of the My Package package. And here's how you would import that. Import mypackage.subpackage.module3. And I'm just going to copy this line twice and just change the notation to reference module 2 and func2 and module 3 and func3. Save that and let's run that. Okay, there we go. So we successfully imported all 3 modules and called the func1, func2, and func3 functions, and we got the predictable results that we expected. Okay, so let's just talk real quick about some useful ways to use the _init files. So this is a little bit of a clunky way to import all of the modules. There's some helper code that you can include in your init files that will make this work a little bit better. And this is what it looks like. Okay, so what we're going to do is we're going to add some code into the _init.py in the My Package folder. So we're going to do this at the top level of packages. And we're going to enter the following code. So I'm going to say from .module1 import func1, and from .module2 import func2, and then from .subpackage.module3 import func3. And then we're going to create one more variable here, which is _all. And we're going to set that equal to a list of strings. And each of the strings are going to be the names of the entities that we are importing. So func1, func2, and func3. What the all variable does, excuse me, this needs to be _ at the front, is this is a special variable that creates a list that controls all of the entities that will get imported when you use the command from module import star. So when it encounters that, it will go into the package, the double underscore init file, and look for the variable double underscore all, and that will define everything that gets imported with the star import. So if you had some functions that you did not want to be imported, if the user used the import star technique, then you would leave those out of the double underscore all list. Okay, so let's save that, and let's go back to our main.py file, and let's change the way we're importing our functions now. Let's do this. We can do from my package import func1, func2, and func3. And then, for example, we can print, let's just call func1. Sorry, that needs to be func1 right there. Okay, and we'll save this and we'll run it. And there we go. So we were able to run func1 using a much simpler import method here. So from my package, by putting this code into our double underscore init file in my package, what this code basically does is it sort of rolls all of the modules and the functions that we want to easily import, that we want to use in our project. It rolls it up to the top layer of the hierarchy of the folder structure, so that in main.py we can just simply refer to my package as if it's a module. So it's like taking all of the modules in the package and treating the package itself as a module, and we can just simply write from my package import all of the entities that we want. I want to show you a couple other cool things you can do inside of your init.py. Let's make a little space here, and let's create a docstring inside of init.py. And this docstring, let's just say this is a help description of how to use the my package. Okay, so I've just written some basic help, but you can picture this as writing an actual descriptor of what this package is, how to use it. And then let's also create a new variable called double underscore version. And let's just set that equal to the string, let's say 1.0.0. Okay, and let's save that. Now watch what happens when I go back over to main and I need to import my package like this. I need to go import my package. So in addition to my specific function imports, I have a general import of the entire package. And the reason for that is I'm going to print out the help on my package. So I'm using the help function to print out help on my package. Let's save this, and now I'm going to run this code. And then you can see over here in my output, it prints out the contents of the help for that module, including the name of it. So it knows that already from the double underscore name variable. The description, this is the text that I typed in there, so it will print out whatever text you put in your docstring. And then there's also a variable down here, version. And so it says version 1.0.0. That is the variable that we set here, version 1.0.0. So if you're using this package in more than one project and you have different versions, so say for example I'm using 1.01 in this, when I go back over here and run this code again, you can see now that version is 1.01. So by running that help from my main.py file, I'm accessing that double underscore version. So that's another example of types of code you can put in your init.py. There may be other types of global variables that you want to save here that you can access. So let's just create a variable called x equal to 4.567. And if, let's say this is a global constant that we want to use, and typically we would use an uppercase variable. So let's just say I've got this value of x, which is for whatever reason an important number that I need to use a lot whenever I'm using the my package. So I'm going to set the variable value in my init.py, and then in main I can access that. For example, let's instead of printing the help, let's print out the value of my package.x. And there you can see that it accessed and it made that variable available in my main.py file. And I could, of course, up here, instead of importing the entire my package, I could just import x along with my functions. And then I do not need to use the dot notation here. I can just print the value of x. So this is bringing x into my namespace. and I can access the value of x. Okay, so hopefully this video helped you understand a little bit better how to interpret what packages are, how to set up the files and directory structure, what types of code you can put into your double_init.py file, and how to use dot notation to reference all of the entities in your modules that you want to access in your main.py file.